Hi, I'm Jason with Lily White Water Solutions, and I want to show you how to model water rights accounting using the IAMDD model. So what we'll do is use this hypothetical model I have where we're irrigating 3 different fields. The first thing I'm going to do is turn off the satellite imagery since this is a hypothetical model. We've got 3 different fields here. This top one is walnuts and it's 110 acres, and the irrigation method is subsurface drip. The second field here is tomatoes, 99 acres, and irrigated via wheel line. And then we have alfalfa, which is just irrigated with generic flood. Okay, so if you want to see how these irrigation demands are calculated, you can see one of my other videos where I describe that. But what I want to show today is how to do water rights accounting using this tool. Okay, so first of all, we need to define the water rights. So we can do that here in the library. Go to water rights. And right now I've got 2 set up. WR1, it's set up with a maximum instantaneous flow limit of 1200 GPM and an annual allotment of 450 acre feet. The second one, WR2, is set up with a maximum instantaneous of 1000, annual allotment of 350. And so with this model you can mix and match water rights to any number of turnouts in the model. Right now I have just a very simple system here. So I've got an infinite water source here. You can imagine this is perhaps something like maybe a canal or groundwater or something like that. But the water right for this farm requires that the delivery from this pond right here be within the instantaneous flow and volume allotments that were defined in those 2 water rights. So we have 2 water rights that we need to apply to this point of diversion from this pond, is what we're going to say here. Now I know this icon looks like a tank, but in this tool we can define these as ponds. If you go here to the library, go to tank geometries, we can have any type of geometry that looks not like a tank but like a pond shape. And so this is defined here by simply adjusting these numbers. So for example, you can change the shape and then it shows you what the shape looks like. So that's the pond. And then we have this pump here with a design flow set point at 2500 GPM, and it delivers water to these 2 fields via these 2 pipes here. Okay, so if we don't change anything about the operations, the way that the model works is it looks at the ensuring that we stay far above the wilting point of the crop and below the field capacity, and just pump as needed to maintain that soil water depth over time. And it also looks at the pressure at the delivery point that it must be required for that. So for example, in this case we have subsurface drip irrigation. If we go up to here to the library and go to irrigation methods, then for subsurface drip you see that we need at least 20 psi. So if the pressure ever drops at this point below 20 psi, then we will not be able to deliver. But in that besides that, we will always be able to deliver as needed, and so the model will just figure out when that water needs to be delivered that way. So if you look at this field here, it shows the results down here in this plot. I can double click on that and show more detail. So right here we can see that what we're trying to do is stay between this orange dash line and this blue dash line. The blue dash line is the field capacity. We get up to about 90% of that, and then we stop irrigating and it drops down. So this is all automated by the model to stay within that zone. The problem with this is that we do this with both of these fields combined, and then we don't have a way to control the overall flow at this pump that delivers to those 2 lines. So what you'll see then if we look at the pump flow, you'll see that there are times when the combination of the two fields are being irrigated at the same time. Therefore, we have a maximum flow rate that exceeds their water right. Okay, so what we can do in this model is we can do an accounting of the water rights based on the flows. We don't when we apply water rights in this model, it doesn't change the operations, but it allows us to do an accounting. Okay, so let's see how that's done. Just to review, go to the library, go to water rights, make sure we have these set up. Then we can go to the point of diversion. In this case, it's right here where we're pumping out of this water source. And I'm going to check this box that says track water rights. And I will then add both of these water rights, number 1 and number 2, to this diversion point. Okay, so now that both of those water rights are applied, the first one on the top is the highest priority. That's the one that will be used first, then the second one. And when I say it's being used, we're just going to be accounting against that when we're delivering water through this pump, and it doesn't matter which field it's going to in this particular case. So keep in mind that you have all the flexibility depending on the configuration of your setup to apply water rights in many different ways. Okay, so now that the water rights are set up, now we can run the model and then we can see the accounting and how it works. So we run the model again, go up here to results, go to water rights accounting, and now what we see here is that the highest priority water right, we used up as much instantaneous flow as we could up until the limit, and then we move into the second water right. So the first one is compliant because we used what we could of that one, and then we moved to the next one down, and that was the only other water right that's there. And you can see we went over that because there were times, and this shows the peak flow during the simulation, there were times when both of the fields were being watered at the same time. Therefore, we exceeded the water right as far as the max flow limit goes. You can also see over here that our total volume extracted is underneath our annual volume limit, so we're okay there, but it's this peak flow that we're off. Now there's also unaccounted for demands in our model, and that is just happening over here in this other line in which we did not apply any water rights to. I just wanted to show that how the model will look at anything where we have not applied water rights and tell you that, okay, there's something that's not accounted for, and that's this pipe over here. But we're not too worried about that right now. What we're trying to do is change our operations so that we do not exceed the instantaneous flow limit of our water rights. So the next thing we want to do is look at rotation scheduling. So we'll go up here to the library, go to delivery schedules, and now we can set up any combination of scheduling of different schedules. So I've got two schedules, S1 and S2, and I have these set up to be about 150 hours long for the first schedule. And that doesn't mean that necessarily that you will water for 150 hours in a block. It just means that that period of time is set aside for that one particular, whoever's going to be using that particular schedule. And it goes on a 14-day rotation interval. So for 14 days, we do these. We have this schedule. It'll just repeat. After 14 days, we'll start over and have this 150 hours. So you can set this up to be a 30-day rotation or a 7-day rotation or anything like that. And then we can set up the next one here, and we can have it make sure that it starts at or after the end of the first schedule. So you can see down here it says the offset is 160 hours. So we can set it to be exactly at 150 or something close to that if we want. And then we can just set this this width here to be also 150 hours. Anyway, so you have all the flexibility you need to add these two schedules. So now that we have the two schedules defined, now we just need to go to each of the actual delivery points and set the schedule. So we can set up a schedule for these pipes here. We'll say this is schedule 1, and go to this other pipe and say this is schedule 2. And now that we have those on different schedules, now we can run the model again and see how it performs. Okay, so now that's done running, and now what you can see is the pump is now actually never exceeding 2,000 GPM, because we have staggered the irrigation to both of these fields. And if we look at one field and the other, you can see that we're still not drying out the field. We're still able to meet the irrigation requirement for those crops. And then we can go up here to results and look at water rights accounting, and you can see that we are compliant on both of those peak flows for those two fields. So this is a powerful tool to enable you to ensure, if you're trying to figure out, whatever system it is, to make sure that you're compliant with the water rights that are available. And you can have any combination of multiple water rights per turnout or multiple turnouts with all of them can have one or more water rights associated with them with different priorities as well. Well, I hope that was useful. If you want to play around with this model, you're welcome to do so. All you need to do is go to my website here at lilywhitewater.com and go to products and click on the IAMDD to play with it yourself. And I do welcome any comments that you might have or questions. Thanks for watching.